Okay, so let's review what we've done so far. You see, in the second lesson, we discussed LCM and we discussed HCF. LCM was more useful for fractions. HCF is going to be very useful for factorization. Right, so HCF will be more useful for factorization. All I want you to remember for now, is that the reason this is the case is because we are using it to simplify. And we are trying to do so in the simplest way possible. Remember how I brought up the whole idea that this is the lowest and that is the highest. So therefore we're going to get the answer simplified in the simplest form. Remember I brought up that whole point? That's exactly what we are talking about here. This is the reason why we're trying to take out, because see, HCF is the highest number that is divisible by the numbers in question. It's the highest number. So if we're going to take out that factor, it's going to be the highest number that is divisible by each of the numbers in the terms. But this will not make sense because we still have to discuss reverse, or we still have to discuss the distributive law in reverse. So for now, do not worry about factorization. Let's focus on products. Just a general overview of what we are talking about, okay? Okay, so now we can discuss products and factorization. But let me give you some brief introduction and start linking everything that we've done thus far. We've said that LCM relates to fractions and HCF relates to factorization. Again, I need to remind you that we are using the lowest common multiple and the highest common factor. So between two numbers, what is the highest number that can be divisible between those two numbers? And the reason we do that is because remember we said that the only two things that we do in maths is solve or simplify. And if you simplify, you want to simplify in the best and simplest way possible. So we are trying to take out the highest number. Right? So if we look at it from degrees of comparison, it's the highest, it's the third degree. Like good, better, best. Right? So that's what you need to remember. So now, before I discuss the factorization module, we have to elaborate on products and the different types of products that you do get. Right? So let's work with that. Let's write this heading. The products of monomials, binomials, and trinomials. Right? So products of monomials, binomials, and trinomials. Right. So firstly, before we do all of this, what is a monomial, binomial, and what is a trinomial? These are basically talking about the number of terms that we have in an expression. It talks about the number of terms that we have in an expression. So now what's very important is let us define this word terms. So we've already done this extensively in the algebraic expressions module. However, I'm going to give you a brief idea of what we are talking about. So for example, we spoke about minus 2x squared plus 1. We said that the plus sign separates terms. So in this expression, which is a collection of terms, we have two terms, right? Then we said that the number in front of the variable is what we call the coefficient. So minus 2 is the coefficient. We said that the minus sign is the sign. We said that the x is the variable, right? The 2 is the exponent, and the 1 is the constant. It's constant because it does not change, right? 1 does not change. So now, looking at all of this here, we also elaborated on the idea that we said that the plus and the minus sign separates terms. And we said that the multiplication sign, the division sign, and the brackets groups terms, or they join terms, right? Joins terms. Now I must remind you, right? That this here will become very important when we start discussing binomials, about the whole idea of grouping terms, right? Okay, so let me give you an example of a monomial, a binomial, and a trinomial. Then we can extend our discussions to the products between these, right? Between two monomials, between a monomial and binomial, and a monomial and a trinomial. Right? So then we can start extending our discussion and then go back to factorization. So looking at this here, you can see that 2x squared is an example of a monomial. There's no plus or minus signs. It's not separating any terms. It's just a term that stands on its own, right? 3x squared yz is an example of a monomial. So this is what we call a monomial, right? Then let's look at number 2. If I gave you 2x squared plus 1, if I gave you x plus y, this is an example of a binomial. A binomial because it has two terms, and there's a plus sign separating those two terms, right? But I have to elaborate on this idea because what we could have, this is a plus sign. What about the instance where we're given brackets? You see this here? You see x minus 1 and x minus 1. this is also what we consider a binomial, because there's two terms, one term here and one term there, right? So if you look at this from the perspective of brackets, the brackets are grouping the terms. So although this is two terms in this bracket and there's two terms in this bracket, when you group them, you're actually grouping these two terms separately. So that's the reason why we're saying that we have two terms. Okay, if I give you the example 2x plus y into x plus 1, these are two terms. This is a binomial because there's two terms, because the brackets are grouping those two terms, right? If you look at number 3, right, so this is the two ways you could get a binomial. The first case is where you have the brackets grouping them, and the second case is where you have the plus or minus sign separating the terms. And lastly, we look at a trinomial, 2x squared plus 3x plus 1. That's a trinomial because there's three terms and the plus or minus sign separates those three terms. Okay, so now that you have a general idea of what each of these terminology means, now let's talk about the products involving them, right? So let's look at the first case, case 1, and I want you to write it exactly as I'm doing it, right? So now we're going full on into products, some monomials.